Hi, everybody. My name is Rob DeFeo, and I'm the founder and the CTO of MailChain. And at MailChain, we do something that's it's incredibly simple. What we're doing is we're adding a communication layer to all blockchain protocols. So for those of you familiar with blockchain, you have an address, and with that address you can transact. And transacting is very, very powerful. But you can't talk, you can't communicate. And we believe it's the missing piece, or one of the missing functionalities across blockchain. So what we've set out to do is build a messaging layer, on top of blockchain so that people can communicate and be able to move faster in this space. However, to do that, we've had to build things securely. And the security that we've had to build is very different to what we build in Web 2. And through this, we've learned a lot of lessons. And some of these lessons is what I want to talk you through today. And I'm going to try and start off by explaining what is Web3. And the problem with this, I racked my head for a long, long time, is I can come up with another definition, one that attempts to explain it, but it's going to be different to everyone else's definitions, and we just end up with yet another one. So instead, I want to give you some of the properties that it has. I'm going to explain to you some of the features and how these features are created and what you can do with them. I think it's more useful because in the end, these are the features that you'll use as Web 2 developers, new Web 3 developers, or experienced Web 3 developers to go and improve your products and your systems wherever you're working. So let's start off like this. In a moment, I'm going to ask you to put your hands up. And when you put your hands up, I want you to focus on somebody you don't know next to you, either in front of you, behind you, to your left, to your right, it doesn't matter. So everyone humor me, phones down, one hand up. And keep your hands in the air. That's literally one person. Come on, everyone put your hands up. Thank you. Now, I want you to think like this. Keep your hand up if you're willing to tell the person that you don't know your first name and your last name. Your date of birth. What about your job, your marital status? How about a photo of your passport? Your mother's maiden, that one got it. Your mother's maiden name, the name of your first pet. It starts to get really worrying. We've got one person with a hand up, you're very generous, and I've probably got into your bank account by this stage. But we commonly do this. The amount of times I've given my passport to someone, that piece of information to prove my identity, or my driving license to prove my identity, but I gave them my address. I gave them my date of birth. Certain countries, I gave them my height, my eye color, hair color. This is all information that wasn't needed, but we gave it away freely. And the technology itself, the user interfaces, the free products, they create this disconnect. We would never do it in real life, but we do it all the time when we sign up for something. So in Web3, one of the most it is a promise of a fairer internet. And you'll hear terms like identity, decentralization, trustless, permissionless, and they're confusing terms. And individually they don't mean very much. But when you combine them together, you can do something very powerful. And I'll be honest, it took a very, very long time for this to click for me. But now it's clicked, or clicking. I'm realizing you can do things in Web 3 that were just not possible before. And it's kind of that promise that we expected with the existing web. But these principles, they evolved out of necessity. And they prevent things like sharing your data with everybody, your privacy, application lock-in, and the lack of ownership around your identity. So the thing with Web 3, though, is it's not quite there yet. There's stuff missing. It's still pretty difficult to use, but it's moving very, very quickly. And these are problems that impact everyone's lives. We've all used systems, or we've all heard about companies that maybe leaked a little bit of data, or they shared your information you weren't very comfortable with. And it was in the T's and C's, and it's a great product and it's free, but we're starting to be a little bit more aware about what we do with information, our identity, and how we should be using it. So Web3, we talk about identity. And it's really multiple identities. So when you first went online, depending on your age, you'd signed up for an email address. In Web 1, that was all there was. Use an email and a login. And with that email address, you did everything. I have like 2 personal email addresses. I've got a couple of work ones for various different jobs, but that's it. And I use this for everything. So it's all connected together, whether I like it or not. And there's many cases that are just banal, that I don't want to have connected. Now, Web 2 did something pretty interesting. You have the social login. Log in with X. Now, this is quite nice, because you don't have to put your password everywhere. But that X, whoever owns that, has this overview of what you're doing. And it's a very valuable and powerful overview. But it's not something that you should give away freely. It's your information. It's your activities. Now, with Web3, it takes a different approach. Because it happens out there in the open, you have multiple identities. Different identities for different things that you do. And you don't want to link these identities together. And with our messaging platform, one of the key things to do was to allow people to safely add multiple blockchain addresses so that they can communicate with them addresses, see it all arrive in one place, but for us to never know that they're linked. There's no way that we can look inside the data and have any idea what's going on. We're like the opposite of big data. We just have nothing to harvest. And it's a very comfortable place to be for us. And it's the thing that people should be wanting for, should be asking for. So with Web3, you own your identity. It's not issued like a driving license from your government. And it's not rented from a provider like the handle on your social media. It's yours. You create it, and you bring it with you. But because you created it and you bring it, you're responsible for it. We're so irresponsible. Like, I forgot my password, can you reset it? That's gone. Like, it's your identity. You're the only one that has that. So it does bring different responsibilities. With ownership, you have responsibilities that you don't have when you rent something. We know this when we rent a house versus buy a house, a car, anything like that. So, decentralization. This is a word that really, I'd say is the one that kind of people really associate with Web3. And it's, at this very high level, it's kind of just means, instead of large parts of the internet or successful companies owned by a very small number of centralized entities or individuals, the ownership gets distributed amongst the builders and the users. And to me, that's super powerful. That should be a fairer way of doing things. And unlike normal distributed systems that we work with in the cloud, this is unkind distribution. You don't know what machine is running. There's not the same type of compute, the same type of throughput. You don't know if they're doing it properly, the way that they should be. So you can't trust what people are doing. And this is a really core concept when you combine it together. So trustless, it's a difficult feature to explain or understand. Like, what do you even do with trustless? We spend all our lives trusting people, trusting organizations. And most people trust people at big organizations because we can't operate without it. It's dangerous to our lives. We'll be left on our own. But there's some pretty good signs that you shouldn't. Now, imagine it like this. If an individual proposed to you the terms and conditions that you'd see when you sign up for a product online, you would never agree to talk to that person. Like, that's a lot that you're agreeing to. And I'm guilty of this. I don't even read the terms and conditions. I just sign up, it looked pretty, the logo was quite nice, and it's a free product. I just get on with it. And actually, what choice do I have? If I don't agree to it, I just don't have a smartphone. Like, we're so, compelled to do these things. And it takes a long time to build trust. And it can be lost very quickly. But better still is you don't trust. You don't need to trust. Instead of trust me, let me prove it to you. So we use proofs in place of trust. And that, when you flip that round, that is incredibly powerful. I stop needing to trust you or anyone else. Instead, I'm just going to prove what I've said. If we did more of this in life, I think the world would be so different. And trustless is a necessity. Because if you're running something in a decentralized way, you can't trust that very respectable looking organization. You don't have the option. Anyone can go and run part of Web3 as they feel like. It makes things really interesting. But it means that your data needs to be super private. It can't just be private when you send it to them. and then they're able to view and work with it. It needs to be private when you send it to them while it's there and on the way back. So Web3 really doubles down on some of the existing principles like encryption, hiding data in plain sight, and uses some advancements like zero-knowledge proofs. So that's been able to prove something, but without revealing the value of it. So think about that in the exercise before. I can prove my date of birth, but without revealing what it is. And replacing trust with proofs, it stops having to, trust the most respectable looking person, organization, entity. Instead, you prove it. So permissionless is like fun, it's for the child in me. You don't ask for permission, you just do it. Anyone can run the infrastructure. Anyone can access the code. Anyone can query the database. It's this, I don't know the word for it. It's a big, global, open thing. It's like monolithic data application world. You can just plug into it. But it's loosely connected. There's no kind of formal rules. You can go grab data from here, run a contract over there. And that means that people can experiment very, very quickly because you don't need to ask for permission from an entity. You can just go ahead, try something, see if it works. Good chance it's not going to, but you can see if it works. And it really makes that iterative process of development fascinating. The speed that Web3 has grown over the last few years, I think has outstripped anything that we've seen. But it's still super early. We're still figuring out what it is and what it can do. Now this is my favorite bit. As a developer, this is where it really comes home for me. The code is king. It is the most important thing. Because the code executes. And it executes out there on the various blockchains, and it executes without asking for permission. It goes and does what it says to do. If you don't like the results, you can't complain to my manager. Write a new piece of code. Get what you're looking for. And it's really, really powerful, but it puts you, the developers, at the center of what's happening. Now, with cryptography, it has a different heart. There's distribution. Distributed compute is complex. But cryptography is really at its core. Without cryptography, Web3 doesn't exist. And Web2, don't get me wrong, it uses cryptography, it uses for encryption, but it's like a feature that got added. It's something that, you could do without it. But with Web3, math is the heart. Okay. So I'm going to step you through some cryptography. Now, bear with me. I'm going to keep it friendly, but we're going to go into some detail. And actually, it's pretty simple. There's really just a few simple ideas, and then we can combine them to make it a little bit more complex. So we start off with a source of randomness, one-way operations, deterministic. I'll explain each one. And we can combine them together, and we can make some hashes and key pairs. So first of all, to you in the audience, you don't have to put your hands up for this. It was hard work last time. But what number looks the most random to you? Yeah, I saw someone point to this side here. There's a couple of pointing there. Okay, a few there, number 3 over there. No one's really picking B. I don't know why. I saw a few more people picking A than C. I'll be honest, because we're all friends. I actually just typed in B. I pressed 9 quite a few times. I didn't think I was going to fool many people. A, that's my old telephone number backwards, so sorry to you guys. Now C, that's actually a random number. I did press the random number generator about 10 times to get something that looked not very random. And the point is this, they could all be random. How a number looks is not an indication of its randomness. It's something that really tricks the human mind. The most important point is the source of your randomness. Where did you get it from? Now, people are terrible sources of randomness. I have so many usernames on test systems that are like JDGHGY because they're just the numbers in the center of the keyboard that I'll bash when I'm trying to get a new username. And one of the biggest mistakes that you can make is using math.rand. So it's a great way to get a random number, but it's not secure. And what I mean by not secure is if you apply enough compute at it, you can start guessing what the random numbers can be. So in cryptography, you need to use a secure source of randomness. And that typically comes from the various crypto libraries inside whatever programming language you're using. Now, the second important concept is one-way operations. Some of these cryptography operations, you can go from one direction to the other, but you can't go backwards. I tried to picture in a waterfall. Like, you can go down that waterfall, but you're not getting back up it the same way. And it means that you can take a value, say value B, you can apply a function to it and get value A. Should have done that the other way around. But you can't go back again. And this is incredibly useful. But it is that simple. Now, for one, even more simply, doesn't matter what programming language you know, that's going to be quite simple for you to translate. It doesn't matter how long you leave this program running. It's not going to throw that error. That is an error that you do not need to handle. If that error gets thrown, we've got bigger problems in the world, and I don't know what's happening. And this is what deterministic means. It means you do the same operation, you get the same result. Simple? Okay. Let's combine a few of these together. Now, we'll just recap them. Secure source of randomness, one-way operations, and deterministic. So cryptography is complex in how it works, but what it does is pretty easy to understand. So we're going to look at how we combine them together. So let's take a hash. A hash is an output of essentially what looks like random values. So you take an input, you apply a function, and you get a constant length output. No matter the size of the input, you're always going to get the same length. And these are one-way operations. You can't take the output and get the input. You can't reverse that hash. Well, at least secure ones. Deterministic. You put the same input in, apply the same function, you'll always get the same output. And the best hashes, they're quick to compute. You don't want to spend a lot of time doing this. It's basically impossible to reverse them. You'd have to go through, look at all the initial pieces of data to try and get one that matches. And you can't find two pieces of data that will give the same output. And one of the ones I really like is you make one small change to a piece of data and the hash is completely different, which makes it very difficult to break. So if we look at this in action, we've got a message here. It's me talking to Tim. Tim's the boss. And that's the hash. Now, this is me talking to Misha. Misha's over there somewhere. She's the most important one. And that's the hash. The difference is tiny. It's just a few characters different, but the hash is completely different. And the hash it's kind of like a tamper-proof seal, because that's the output for this one. If I go change something and try and say the hash is the same, you'll calculate it yourself really quickly, and you'll see it's not. You'll see that something has changed along the way. So key pairs. Key pairs. They need a secure source of randomness. You don't have that, your key pair is going to be someone else's. So don't use math.rand. Your key pair is a private key. It can never be changed. And it must be kept secret. If I flash the key pair on here, even for like half a second, it's gone. Someone's recording it. They'll play it back, they'll slow it down, in that moment it's gone. So you've got to be very, very careful about how you manage your key pairs. And private keys, they use one-way operations and a deterministic operation to create a public key. It's not like a hash though, because there's a special relationship between a private key and a public key based on elliptic curves. Totally out of scope for this. But basically, it means that you can use these key pairs together to do some pretty interesting operations, like signatures and encryption. Now, the cool thing about public keys is you can give them to everybody. It's fine. It's like a username. Not a big deal. And actually, you're going to use that, the person that receives it's going to use that public key to prove or to verify something you have tried to prove. So this is what a key pair looks like. You generate it using a secure proof of randomness. From the public key, you'll get from the private key, you get a public key, and that is what they look like. That is not super user-friendly. I'll be totally honest with you, but it is super powerful. So that is the basics of cryptography. There's a few very simple operations, and we combine them together to do something pretty interesting. But let's bring that to life in our situation. Like in mail chain, like why is that useful? We build a secure end-to-end encrypted messaging platform. When I say end-to-end encrypted, it's not like I send it to the server over HTTPS so no one can read it along the way and the server decrypts it and then stores it or reads it and does what it wants to. I mean, the client sends it, client encrypts it, sends it, server stores it, does what it needs to, can't read it, and then sends it back to the client when they ask for it. Now, before we go on though, there is one thing that I want to say about cryptography is you have to be more responsible than we normally are. Like I said, I forget my password, I can go phone up, not phone up, I can raise a support ticket, hit a reset password button, and fill out some information, I'll get my password back. But that doesn't exist in cryptography, because you created the private key, and you own the private key. You never give the private key to anybody, only the public key. And there's this temptation. We're all hackers here, and hackers in the sense that you just throw stuff together to figure it out, not hackers in the sense you're trying to break it. And there's all them simple things, and there's a few more concepts, obviously. You can combine them together to create some pretty interesting stuff, but stick to proven patterns. There's a lot of work that goes in cryptography to come up with proofs to show that it does what it says on the tin, and it's safe, because all this goes out in the public, and anyone will try to break it. So please stick to the proven patterns. There's one thing you remember, it's that. That's why we tried to make a pretty picture. So please remember that. Now, your key pair is your identity. And this is another one of them sort of linking concepts that we gotta get there. It's you, and you can bring that identity wherever you want. And you can take it and use it as you see fit. Now with your identity, you can do a couple of extra things. You can encrypt, and you can use encryption, and you can use signatures. Let's go through these. So encryption, it's like a natural property of Web3 identities, because you encrypt with the public key, and you decrypt it with the private key. And Web2 uses encryption, it certainly does. So as you said, what goes across HTTPS is encrypted, and the server can then read it and work with it. Web3, we have to go further. When the client sends the data somewhere, you can't have the server decrypting it because it's distributed all over. It's trustless, it's permissionless, anyone can run it. You can't assume where you're sending the information is safe. So we use cryptography so that you can still be safe. And it's different. So we have the encrypted in flight and at rest, but instead it's client encrypted in flight and in rest. It's the whole damn time. So this is what it looks like. So that's me saying hi to Tim again. I can use Tim's public key to encrypt that. And that is what you'll get. That, to anybody looking at it, is essentially a random set of bytes. I can send that in the public quite happily. I'm leaving it on the screen. You don't even have to play it back. You can just type it in. But it's useless to you unless you own Tim's private key. He can go find that message, and he can take it, he can use his private key and decrypt it. And he'll see, hi, perfect. He's the only one that can get that answer. Now, that's all very good, but and I've been able to move data across safely out in the open so only one person can read it. But who said that I sent it? Like, it doesn't prove that. And that's what signatures are for. So signatures are created by the private key. So when I send the message, I'll use my private key to sign the message. And with the signature and the data, using my public key, which anyone can have, you can verify. So it uses that hash, so the data is hashed, it is then signed, and then the person with the public key can check whether it's real or not. So in this case, I will sign it with my private key, I will send it to Tim, and I will send the signature, the message, and the public key. When Tim receives it, he will use my public key, the message, and the signature to find out if it came from where it said it came from. Don't trust, verify. So, and this is the other way to explain it. I can never do it first time round. So this is the other way to think about it. Private keys can sign and they can decrypt. Public keys can verify and they can encrypt. That's it. But being able to combine these things together means that we can create an end-to-end encrypted messaging platform for any blockchain address out there and build it in such a way that you can safely link messages, message anybody without us, anyone running the protocol, anyone intercepting the messages, knowing. Only the intended recipient can receive and view that information. So, like, how can you use this? I'm not suggesting you'll go quit your jobs in your fantastic Web2 companies and go start a Web3 company or find one to join. But if you do, we're hiring, so please, like, find me afterwards. But the principles are useful. There's something that we should be using. Cryptography is incredibly powerful, and we should be using it more in our day-to-day lives. But if you are thinking of going and starting a new business, and you have the opportunity to think about doing something in Web 2 and Web 3, think about this. Do you really think that you can build a company that will be... Do you think there's a better way to build a company that you, the users, can participate in the company, the government decide who does what, you get to share in the success, and the builders, the people that come work for you, the people that come write stuff in open source, the people that run your infrastructure also get part of that reward, rather than a few people at the beginning and a few investors can take advantage of it. But Web 3, it builds on top of Web 2. It's an iteration, it's not a reinvention. There are some things that are invented from the ground up, but essentially we're using some of the magic that Web 2 has. And infrastructure is one of them. Web 2, has proven the scalability. AWS is a fantastic example. It scales, it's reliable. We're not reinventing that. There are some fascinating creations of new infrastructure in Web 3, especially around storage, which we're certainly looking at, but we use the proven technologies, the proven services that providers like AWS have so that we can build on top of it, and we can apply the cryptography. We just take things really, really seriously, like the encryption at rest and in flight. We go further, but we still use the underlying infrastructure. It's incredibly valuable and it works. Now this is, it might not feel like it, because the words are super confusing, and if anything, I hope I've managed to remove some confusion. But it's open to everybody. There's no, gates. And actually, because it's a new concept, you have new people entering the space that never were involved in some of the previous technology iterations. It's basically essentially open source. And Web3's mission is to do something fundamentally good for the world. It's so that you're able to use products and share and use your data safely. And data is one of these things that we really struggle with. Like, if I ask you to give your phone to the person next to you, you don't have your phone anymore. You didn't even want to do it. Yeah? Unless she gives it back to you. Then you've got your phone again. But if I ask you to share your date of birth with the person next to you, you can't ask for it back. It's gone, it's shared. That person can pass it on all they like. And that's one of the things that is really, really confusing for everyone. Like, I struggle with it. It's fantastic when you're doing a startup and you share an idea. The other person's got the idea, but they're going to bounce it backwards and forwards and you'll make it better. Not so great when it's your personal information. And with Web3, the different types of personalities and people are entering into it all over the world. I've never seen such a disconnected set of people with different backgrounds come together to try and build something with crazy ideas that when you have a group of your friends in the same room, in the same city, in the same backgrounds, will just never come up with. And things that just seem so crazy and mad, but they work. And people are iterating and building incredibly fast. And the other part of it is it's built in the open. What we're building is open source. It's available for anyone to be able to inspect, contribute to, and be part of and learn from. We do a lot of our thinking in the open. Our community is open. They challenge us continuously. We're figuring out what we do and how we work with them. And we welcome contributions. Obviously, co-contributions, they're fantastic. We love that. Ideas were brilliant. People challenging us, saying, why is it done this way? Why doesn't it work? We want to be as open as we can about our designs and our decisions and the way that we build things. And the infrastructure, the protocol that we're building will be open. Anyone can take part, run part of it. Now, as a developer, how cool is that? If I can take part in the success of something, normally, to take part in a successful startup, you need to be A, there at the beginning, B, have a lot of money, C, have the connections, and D, a little bit of luck to pick the right one. But it's not, I don't have that. I've got a little bit of a brain, some skills and some knowledge. I want to use that to be able to take part in the success of systems. And in Web3 you can. You can use your knowledge on code to write smart contracts. You can use your knowledge how to run infrastructure, to run part of their infrastructure and be rewarded for it. And this is all done out in the open. And it builds on the open source principles that are inside of Web2 and the infrastructure, but it's all opened out. So, I think I've managed to leave enough time for questions. And I really welcome any questions that you might have. And if you're not keen on asking in front of everyone, I'll be around. But there's a lady here with a big microphone, and there's someone pointing different hands as well. So anyone who have any questions, please raise your hands or at least give me some ice.
Hi, thank you very much. It was really, really interesting. What's your business model for this service?
Yeah, sure.
Very simply.
This is where I really wish I had Tim. So the business model essentially is message fees. So when messages are sent, think like SMS, there's a fee. Same with email. We never see it because we're people, we pay for a subscription of the service, or maybe not. But there's a tiny, tiny transaction fee and everything. Now, I don't think users want to pay for sending messages, if I'm totally honest. But businesses or heavy users are willing to pay. So the idea is that we'll use the incomes from people sending many messages in a short period of time, recycle the fees back to the users so that people can communicate as they would do. I might be a bit of an exception here, and some of my friends would be annoyed about this, but I receive many more messages than I send. I can't keep up with it. But I think that's normal for most people. It's only really businesses that are sending more. But at the moment, most business models around messages are like, we'll store all your messages, use that information to make money somewhere else, rather than the businesses that send your information are able to circulate the money back to you.
Hi, that was really interesting. Do you ever worry about like organised crime or anything, like messages going through your system?
I always worry about organised crime.
Yeah. But I guess there would just be like no way that you could ever know.
We've built an open protocol. What goes across that protocol, we can't see inside of. And there's, you can say it's very similar to the internet. Like what goes across TCP/IP, like goes across TCP/IP. What happens with dollars, out on the street happens with dollars out on the street. Like we will build in, clients that operate in the jurisdictions they operate in, and anyone that we're told that can't use it, we'll turn them off. But their identity can move somewhere else, and different jurisdictions have different rules. So we're building the underlying layer, and we absolutely do not want anything like this on there. The lady was there. Hello, do you have the microphone? Sorry. Just here.
Hi, great presentation, thank you. So in a world where fake news are a better reality, do you have some concrete example where Web 3.0 can help to avoid it, fake news?
Fake news. I can't say I have a concrete example. It's not something I'm close enough to, but when I personally look at a news article, I'm always looking for where did this come from? And if you go follow it down, you end up realizing, where did that one come from? Where did that come from? And you find that the source is often not very reliable. But there's no verification that happens. We're so wanting to get information quickly, we're not too keen on getting to the bottom of it. And the only thing I can say is, the principles in Web3 exist on don't trust me, verify what I'm saying. I'm going to give you all the information needed so that you can take that signature and check it out. Now, it's up to you to go do that. We make the clients and make the software so it's extremely easy, and we make it automatic, but ultimately, there's more responsibility on the user to take part in that.
Regarding encryption and anonymizing data,
I'm so sorry. I think there's just lots of noise. Can you say a bit louder?
regarding encryption and anonymizing data
Yeah.
using zero-knowledge proofs, what are the names of the cryptographic ways or products to transfer that data?
So what are the cryptographic methods
Yeah,
used?
you say there's ZK proofs, that's the concept.
Yeah.
But are there, products that teams can employ on a blockchain? Does that question make sense?
Sorry,
Well,
can you
what
say
do
the
you
last part?
actually,
Can you say the last part again?
what are the names of these actual tools or products?
Okay. Yeah, totally. So just to repeat the question, so it's asking what cryptographic methods, tools that we use. So we use a bunch of hashes, typically from the SHA-3 family. They're more secure than other ones. Different hashes have different properties. So we're looking at ones that allow you to prove trees in there, so like a Merkle tree. For cryptography, well, because we support multiple blockchains, each blockchain has their own key. They make a choice about what elliptic curve they use for their key pairs for signatures. So we respect those particular choices. We integrate all of them. So Ethereum and Bitcoin and other ones based on this use the SECP 256K1. Sorry. If you look at Substrate and others, they use ED 25519. They're based on the X 25519. And there's also the SR 25519. So they're the different elliptic curves. I'm losing people desperately now. And then for encryption itself, we use the ED 25519 key. So we convert everything into this, the messages for that. And we use key exchanges. And we're looking at using the, what they call it, X3DH. So it's like multiple key exchanges, which allow you perfect forward secrecy. So that means if, for example, you accidentally leaked your key, you can only read that one message, not the ones before, not the ones afterwards. Super interesting property. And we use the NACL or the sodium lib library for encryption as well. I'm happy to go through more stuff with you later as well. And there's one person right at the back in a blue hoodie. We've lost the microphone again.
Hello?
No, okay, one more afterwards.
Me. I have a question.
Please.
If we own our identity and
Yes.
transactions are encrypted, how social media can target advertising and publicity direct to us?
Oh, I don't use social media very much, so it kind of makes me warm and fuzzy inside when I hear this. It's difficult. They can't use their standard models because they can't see everything that's happening. I think the way that it would have to happen is, I got my identity, my data on my machine. Why don't you send me your code? And if I'm happy with it, I'll let it run over here, and I'll send you the results out. You don't need to know all my information. You just need to know, what's this ad worth to me? So I think it changes where things will happen. I'm not an expert here, but that is how I would do it if I was building a social media platform now on Web3.
Thank you.
You're welcome. There's someone shyly at the back.
Hello.
Hello.
I have a question about SSI. SSI.
For everyone, not for me. Do you mind defining that? Because I got no idea what you mean.
Self-sovereign identity. So
Thank
the identity part. So when issuing a credential to a holder, the most common method I come across is showing a QR code to someone on the website of the issuer typically. But that means that you have to trust the website, which is typically something that you do based on a certification authority that signs the SSL certificate of the website. But then you're kind of trusting a central entity to validate the website. So is there already some kind of solution for making that trustless and decentralized as well? So
the actual identity, when you put it out there, how do I know?
Yeah, the actual issuance, that there's no central governance involved.
Yeah, so this is super interesting. How deep down do you have to go for the source of truth, if you like? And we assume that nothing is trusted. So what we do when you sign up and you register an address, you sign a message with your wallet, MetaMask, etc., and that creates a signature. We publish that signature in the key registry. Anyone can query the registry and look at the signature. That signature is then used, so there's a messaging key in there, and the signature proves that messaging came from there. So that's one proof. The other proof is it came from the key. When we go and send messages or receive them, it uses the messaging key, and then proofs are placed in the message. And then that message is distributed. Now you can read that message, and it looks pretty good, the formatting's about right, but it's not enough. What we do with the SDK and the client that runs on everyone's machine is it steps back at each layer, going through and checking that all the proofs add up. Now that only takes you back to an identity. An identity key is not very intrinsically human friendly to somebody. So people often wrap a name around that identity, so I know that I am me. One of the challenges there is that name can move. The private key never stays the same, but the name can be transferred. And that's where we need to look at the proofs that indicate the state at any given moment of that name. And we're working with the various different name providers to figure out the best way of doing that. Because it's super important that if you owned a name and sent me a message and I didn't check for a week and you sold it, I know that. Because it looks the same at the moment as you sent me a message and it just looks completely fake. Have I exhausted everyone? Oh, I'm very sorry. Anyway, if there was any questions that you didn't want to ask now, I'll kind of hang around. Thank you so much. There'll be a load of really cool talks as well. Please try out the product. I should have said that when everyone was here. And if you got any and you want to find out more, just check out mailchain.com. Thank you.